Okay, so now we're going to talk about single displacement reactions. Single displacement reactions are very similar to double replacement reactions. Here, though, we have a compound in a single element. Thus the name single replacement reactions. If this single element is a metal, then it might be able to replace the metal in the compound. And so for our sample equation here, we have C, which is a metal, replacing A, and now the A is off by itself. If the element that's by itself is a non-metal, then it could only replace the non-metal. And that's what's occurring on the product side here, is C is acting like a non-metal, and it's replacing the non-metal in the compound. The way we're going to tell whether or not it could replace it is we're going to have to go to our activity series. Let me bring that up here. And we have an activity series for metals, and we have activity series for nonmetals. An element that's at the top of the activity series, if it's by itself, can replace any element that's below it. So if we have a compound with zinc in it, any one of these elements above it could replace the zinc in that compound. A common question is hydrogen. Hydrogen here is in the capital letters because hydrogen is typically thought of as a non-metal, and it doesn't really seem to fit in with the group, but hydrogen takes a positive charge just like normal metals do. On the other side here, we have a very short list of non-metals we might encounter. Again, if it's at the top, it could replace any of the elements that are below it. Let's look at our sample equation and we'll come back. Our sample here, we have lithium, that's a solid, reacting with calcium acetate, that's aqueous. So you have to imagine the calcium acetate is maybe dissolved in a beaker and it's aqueous. And then someone comes along and they drop some of this solid lithium into that beaker. Well, if lithium is higher on the activity series, which we can see right here, that's the number one on the list. It's the number one on the list. It's going to replace the calcium in that compound. So on the product side, look, the calcium's all by itself, and now the lithium has bonded up with the acetate. We're going to follow the exact same pattern as we did before. When we put the compounds together, the first thing we're going to worry about is the charges. So lithium's a +1, acetate's a -1, so they cancel each other out. Then we balance the equation. Over here I have 2 acetates. I put a 2 in front to fix my acetates. That also impacts the lithium, so I better come back over here and put a 2 in to fix that lithium. Lastly, the states of matter. This is aqueous because, again, it is on the solubility rules that acetates, there they are, acetates are always soluble. Now, the elements are by themselves here. And when the elements are by themselves, we need to take them to their natural state. Lithium and calcium are both solids in their natural state. They're not in a compound, so you have to put them in their natural states here.